Hello Internet, this is the High School Scientist, and this is the second video where we solve multiple choice questions without multiple choices. And try out the questions in the first video if you haven't already. So let's get started. Question number 6. Which of the following pairs of physical quantities have the same dimension? Well, the answer would be force and torque. To break it down, torque is just force but with an angle. And as there is no way of mentioning angles in the form of dimensional formulas, we can safely ignore it from the equation. And when torque has no angle, it pretty much becomes force. So yes, torque and force have the same dimensional formula, but practically they are different from one another. What is the dimensional formula for the Planck's constant? I have given a short explanation in my previous video about the Planck's constant, so just click here if you wish to learn about it. We know that the Planck's constant is the energy of a photon divided by the frequency at which the photon is traveling. So the expression is energy by frequency. But energy can be expressed in terms of force by distance, and frequency can be represented as the inverse of time. So by replacing the expression with the dimensional formula, we get the dimensional formula for the Planck's constant, which is ml square multiplied by the inverse of time. Okay, moving on to the next question. The velocity of a particle is given by this expression. So find the dimensions of b in this expression. Here we have a slightly different type of question where we have to find b, which is a term in the equation. So we have to keep the left hand side of the equation equal to the right hand side. In dimensional formulae, constants can be neglected, which means that this equation can be 5, 10 or even 100 times more than velocity and it still wouldn't matter. Because it's a constant and there is no room for constants in dimensional formulae. And so we just assign any dimensional formula to A and B. But there is one condition, that the end result should be equal to the left hand side. And so we assign L times the inverse of t square to A and L times the inverse of t cube to B. But why do we have to do this? It's actually necessary. When we equate these values in the equation, we get L times the inverse of t for both A and B. So it becomes L times the inverse of t multiplied by 2, and after crossing off the constant, we get a value which is equal to the left hand side. Thus, the answer is L times t to the power negative 3, because that is what we used to replace it with b. Let's move on to the next question. Find the dimensional formula for the gravitational constant. Well, the expression for the gravitational constant is force multiplied by distance square divided by the square of mass. So just by replacing the physical quantities with their dimensional formula, we get the dimensional formula for the gravitational constant. And by the way, check out this video if you don't know what a gravitational constant is. Moving on to the 10th question. If force is proportional to the square of velocity, then find the dimension of the proportionality constant. Let's try it out. I will solve the question on screen without explaining, and you guys just try to understand. So that question was easy enough to understand. But I don't think the next question will be. And no, I'm not kidding. Just look at this question. A 11th standard student would not even know what this means. But anyway, we all have a lot to learn, so let's start. Well, this symbol means permeability of a substance, and it's called mu. It can also be referred to micrometer or coefficient of friction, but in this context, it means permeability. Now you might ask, What is permeability? Well, it relates to magnetism. It's the property of a substance to allow or resist magnetic lines of force to pass through it, or the degree of penetration of magnetic field through the substance. Well, in other words, how strong should the magnetic field be to penetrate through an object? As a strong magnetic field is required to penetrate through lead, but even a weak magnetic field is enough to pass through iron, as the permeability of iron is extremely high, as it allows the magnetic lines of force to pass freely without any resistance. But in this case, we are using air as the substance to pass the magnetic lines of force. How do I know that? Well, it's given in the question as mu naught. And this tiny circle next to mu represents the lowest possible value for permeability. And as air or vacuum has the lowest permeability, it's represented as mu naught. So the expression for permeability of a substance is Henry by meter. Yeah, I know, this raises more questions than it answers. Now, what does Henry per meter mean? I would suggest you guys to just memorize this part and just concentrate on the question. Because, come on guys, this is just the first lesson and we don't have to go down the rabbit hole. But for those curious people out there, I have mentioned the link to a webpage if you want to learn more about it. And for the not so curious people, Henry is just a unit for inductance. Well, actually we can just simplify it as Newton by ampere square. And so the dimensional formula is ml t to the power minus 2 and multiplied by a to the power minus 2. Okay, but what do I do with this symbol? Well, this stands for permittivity of free space. It's kind of an oxymoron, as permittivity is the ability of a substance to reduce the interactive force between two charged particles. Yes, it only reduces the interactive force between two charged particles if a medium or substance is introduced between them. So it would make sense if I say that the permittivity of vacuum is the least. Hence, the interactive force between the two charged particles is maximum in a vacuum. Yeah, I know this was a really gross simplification of these topics, but I will be explaining them in detail in my future videos. By the way guys, this is just a multiple choice question and we are trying to solve it without the multiple choices. So I guess it's just better that we jump into the simplification part, but I will be explaining it in my later videos. So make sure you subscribe. And there you have it. The answer is velocity. Moving on to the 11th question. Which of the following combinations of these has the dimension of length? So there is no other way, we have to check every combinations and try to solve it. So let's start with A. So these are the dimensions of the Planck's constant and gravitational constant. So now we can simply equate them, and surprisingly A is the actual answer for this question. Did not see that coming. But anyway, moving on to the final question, and yes, I saved the worst for last. Which of the following expression for length is correct? I don't know which stupid person decided to print this question on the first lesson of the 11th standard textbook. There is not a single line explaining permittivity, not a single word about the Boltzmann constant, and still this question is supposed to be solved by a 11th standard student. Anyway, we have a question to solve. Let's again start with A. So we have 4 different quantities to look. First we have permittivity, and it's permittivity of a material. To be precise, a dielectric material. Even then, the formula is just the same, because as said earlier, when permittivity increases, the interactive force between the particle decreases, and when a medium is introduced, well, it just means that the permittivity has been multiplied by a number, and in dimensional analysis, numbers don't bring any value. Hence the dimensional formula remains the same. By the way, it's inverse of m multiplied by the inverse of L cube, which is then multiplied by t to the power 4, and finally with the inverse of a square. And now the dimensional formula for the Boltzmann constant is this, and I have a strong feeling that you don't know what the Boltzmann constant is. So yeah, same advice, stay away from it, just memorize the equation, or else you'll find yourself inside the rabbit hole. But for the curious people, it's just a constant which relates to energy with increase or decrease in temperature. The dimensional formula for the charged particles is A times T, and the dimensional formula for temperature is K. Well, n is just a constant, and so it can be neglected. Now, just by replacing every quantity with their dimensional formula, we can finally start solving the question. Here, when we solve A, we get the root of L, which is not the answer we are looking for. For B, we get the root of inverse of L. Still not correct. Wait, what? C and D are also incorrect? But how? How could every answer be wrong? That is why it's a good practice to read the question thrice. We should not be neglecting n, as it's not a constant. It's the number of charges per unit volume, which means n is equal to 1 by L cube. And so after adding this to the equation, we get the correct answer, which is option B. And that brings us to the end of this video. I hope you learned something, and if you did, then just spread the word. Let your friends and classmates know about this channel. And by the way, if you haven't subscribed yet, make sure you subscribe, and you can watch more of my videos by clicking on one of these boxes. This is the High School Scientist, signing off.